Well, we're working our way through algebra with two unknowns, and today I want to look at graphing with intercepts. We've already looked at graphing with y equals mx plus b, and graphing with intercepts is just a variation on this. Sometimes we want to know what a graph looks like when it's not in the y equals mx plus b form. Now, sometimes we teachers get so much in a hurry when we're teaching Algebra 1, or we get so behind, that we leave out this graphing with intercepts and we just tell kids, always solve for 1y. So some students miss out on this, but it's really kind of an important way of being able to graph an equation. I call it the let's pretend method. What's your favorite number to do arithmetic on? If you have any sense at all, what's your favorite number for doing arithmetic on? Mine is 0. So if we were trying to find the equation of this line, what we want to do is pretend that x is 0 right here. And just to be fair, we'll give x its turn at being 0, and then we will give y its turn at being 0. So let's look at that. If we pretend that x is 0, 0 times 12 sort of wipes out this term. And what would have to be the matching y if x is pretended to be 0? The matching y would have to be what we would get when we divide both sides of this by 8. It would have to be 3. So I'm going to minimize that, and I'm going to put that 3 in there. If I would use the right keyboard, that would be really good, instead of using my Windows keyboard. Now, we've given x its turn at being 0. Let's give y its turn at being 0. Let's pretend that y is 0. And if y is 0, 8 times 0 is 0. This would wipe out. And we would find that the matching x had to be 2. So let's put that in. My goodness, look at that. That was not too hard. We just pretended that this was 0. Why, I used to put my hand over that term and then find out what the matching y was. Put my hand over this term and find out what the matching x was, and you get these 2 points. 0 and 3 are partners on this line, and 2 and 0 are partners. Let's check our numbers. We're right. So now we can locate the points. Let's locate this point, 0, 3. 0, 1, 2, 3. There he lives. Let's locate this point, 2, 0. There he lives. There's the equation of that line. We could actually write the equation. We could look right here and see the slope is, since it's slanted up negatively, it's sinking down to 3. It's y equals negative 3/2 x plus 3. I can see from the graph. Look how easy that was to graph that a line by pretending that the x was 0, and when we were done pretending that the y was 0. Let's do another problem. I think another one, and we should be home free. Let's pretend that x is 0. If x is 0, he wipes out. And negative 6y equals 24. It looks like y would be negative 4. Let's just put that in, negative 4. And I'll bring the marker back up. And now we're going to pretend that y is 0. If we pretend y is 0, this term gets wiped off the face of the planet, and we get 2x is equal to 24, and it looks like x would have to be 6. So let's put that down. Did you see how quickly we were able to do that? This kind of graphing might be easier even than the y equals mx plus b, but it's not quite as easy to visualize. So we have these 2 points. We want to check, make sure we didn't mess up on our division, which we didn't. So now we can locate the point is 0, negative 4, because they are partners in crime. 0 and negative 4, 1, 2, 3, 4. That's a point. And the other one is 6, 0, 1, 2, 3, 4, 5, 6, 0. We have graphed this line using intercepts. Practice it. Get good at it. Have the edge. There should be 2 ways of graphing that you learn in Algebra 1. Graphing with y equals mx plus b and graphing with intercepts. Work on those, and then one of my teachers that came to the lab said, why don't you bundle these 2 things together? So actually After you get good at both of these, you're ready for 2 ways of graphing, which is these 2 programs combined. We're not going to do a separate program on that. Let's look at that. Here you can graph with y equals mx plus b. Y-intercept that, 1, 2, 3, 4, 1, 2, 3. Graph like that. Go back to Descartes, graph one like this. The x, if x is 0, this is a little bit harder. Let's see, 45. That's going to go into their negative 4 times, so the y would be negative 4. And if y is 0, it looks like this is 9. Let's check that. We win. 0, negative 4, 1, 2, 3, 4. 9, 0. We graph like that. Go back to Descartes. Keep going back and forth until you get so good at the 2 ways of graphing. Descartes and I will be very happy. Thanks. Bye.